Greetings, my fellow humanoid dwellers. I create videos on technology and other random things. If you like this video, you might like others. If you don't like this video, you still might like others. Consider subscribing to my channel or checking out my Patreon page. If you already subscribe, hit that bell. In the network tutorial number 2, where we talked about setting up SSH and adding a static IP address to the Raspberry Pi, it occurred to me that there might be some people out there that would have no idea what a static IP address even is, or the difference between a dynamic IP address or a static IP address. So I went ahead and I'm doing this short tutorial on just that, just to kind of explain what IP addresses are and what a subnet mask is. This is not an in-depth course on this. This is just a brief explanation to hopefully give you an idea of how it works. There are many tutorials online that you can go to get more information, and I might even have another tutorial after this one just to go into it a little bit deeper. To start this tutorial, we're going to do it in a little different way. We're going to make an analogy to two small towns that are trying to communicate with one another. One of the towns we're going to go ahead and call Springfield. It's going to have a post office, the name, and then this circle here. We're going to have two addresses in it. We're going to have 105 West Main and 100 East Main. The other town we're going to have is going to be Hillside. It's going to have a post office. It's going to have a 105 West Main and a 100 East Main. Then we're going to have a third town called Anytown. And then we're going to have a piece of mail, and we're going to pretend like that's a packet that would go between computers, but in this case it's going to be an envelope that's going to go between houses. If you were living at 105 West Main and you knew the person that was living at 100 East Main, you might just walk it directly over to them because you would know exactly where they were. You'd have no question. You wouldn't even have to know the address. You may just know the person and just take it right over there. But if you didn't know the person that lived there, and all you had was their address, you might send it to the post office first and then go there. But in this case, all you would have to know is the street address. You wouldn't have to know the name of Springfield. You would just say, send it to that address. Now, if you were here at Anytown and you wanted to send this letter to 100 East Main without knowing the town, you would have no idea it could go to this or to this. So if you send it out, the post office would say, we don't have a town, we're going to send it right back. But if you give it a town, like Hillside, 100 East Main, it'll go right to the right spot. If you were in Hillside and you lived at 100 East Main and you wanted to send the letter to Springfield 100 East Main, you would send it first to this post office. It would probably go to another post office somewhere. Then it would go back to this post office in Springfield, then it would be delivered. So when you think of this, when you think of the computers on your network, you have to think of each house being a computer and having a local address, and then you have to think of your home as being a town. Since your post office assigns your address, this would be considered a dynamic home address. If you made up your own address and put it on your house, it would be considered a static address. Like static on your radio, you can probably foresee that putting your own address on your house could cause problems. In most cases, you want the post office handing out and keeping track of addresses. This would be the best way to make sure people don't put up duplicate addresses or addresses that don't make sense. So now I'm going to go ahead and make the towns vanish, and we'll set up the network. An IP address is built using 4 different values separated by the decimal point, and these values can be anywhere from 0 through 255. Some of these numbers will represent the city, and some of them will represent the device. The thing that decides which ones of these are the city and which ones are the device is called a subnet mask. The subnet mask is built up of the same 4 sets of digits separated by 3 decimal points. Wherever you see the 255 and where it lines up with the IP address, that's the city. wherever you see a 0, that's the device. So on a network, all of the city addresses need to match, whereas on that same network you would want the device addresses to be different. For the network we're going to set up, we're going to use 192.168.3 as our city. In doing that, since we're going to use the first 3 sets of numbers, our subnet mask will be 255.255.255.0. Now this is a very simple example. Not all subnet masks have 255.255. There may be another number in there. But for what we're doing, just use 255.255.255.0. That's what 99% of all homes use. And then also 99% of all homes will use 192.168. something between 1 and 255 as their city or as their home network. And that's what it's called. These first 3, instead of calling it a city, that's your network. Now we're going to go ahead and set up our home. First thing we're going to add is we're going to have a PC, and we're going to give it an identifier of 3. So 192.168.3.3. The next device we add will have to have the same network, 192.168.3, but will have to have a different 4th number. In this case, it'll be an Xbox, and we're going to give it 5. Now we're going to add a printer, and it's going to be 192.168.3 and another different number called 100. And then the tablet, we're going to do 192.168.3.10. Now, in most houses, there's a home router. We're going to add that next. The home router, in this case, we're giving it .1. In our case, for both the Raspberry Pi and in my example with my laptop, I assigned static numbers. I gave them 192.168. something, they were both 1, a .10 and a .5. You could assign every device on your network its own IP address and keep track of them and make sure you didn't duplicate them. Another way to do it is have your router assign the IP address as it sees these come on the network, and your router will keep track of the addresses and make sure they do not duplicate. In our case, though, we wanted the Raspberry Pi to have a certain IP address, so every time we went into it, it would have the same IP address. In these routers, you can set the range. So you can say to the next 50 devices, they are going to get 192.168.3.10 through 192.168.3.60. So that way you know that the devices that are going to get them automatically will be within 10 to 60, and so then you could assign the Raspberry Pi an IP address that is not within that range. So you could give it 192.168.3.70. We're going to go ahead and change the tablet to a Raspberry Pi. And we're going to give it an address of 70. And we're going to make the router give out addresses 192.168.3.10 through .60. So now, if I were to change this printer to a DHCP address, it would give the first address it has, and it would change this to 10. If I change the Xbox to DHCP, so it gets an automatic address, it would change it to 11. And if I change the PC to DHCP, it would change it to 12. Now the Pi is set to a static IP address and the other three are dynamic or DHCP. The Pi will hold the same address if it is powered on and off, while the other three devices may change their IP address. In our scenario, the only device that we want to maintain the same IP address is the Raspberry Pi, so we can reliably SSH into it. In the previous example, I set my computer to static because I did not have a router that would hand out IP addresses automatically. Now, using the mail, this PC knows where this printer is, so it can print right to it. But what if this PC were to say, I want to go to www.google.com? Well, the PC only knows IP addresses. So what it's going to do first is it's going to send the words www.google.com to the default gateway. And the default gateway in these computers and the Xbox and the printer and even the Raspberry Pi is 192.168.3.1. Well, within this router we have what's called a DNS, domain name server. We have the DNS set to 8.8.8.8, a public DNS. And what it does is before it transmits any packets or any information it takes the www.google that this sent here, it goes to the 8888, it transposes that www.google.com into an IP address, and it sends it back to PC3. Then PC3 says, I want to go get information from that IP address, but it is not on my network, so it goes back to the home router again. The home router knows to send it to the outside world. This is the outside world. There's a line to it, and it just goes out, goes right out to the outside world, and then the outside world has routers that know how to take care of the data. The big thing to take away from this is when you're setting up a network, if you have your computer already on, you can go to your command prompt and you can type, if you're using a Windows machine, you can type ipconfig. I know in the Raspberry Pi it was ifconfig, but in this it's ipconfig, and it will give you your current IP address in the PC that you're using and the subnet mask. Based upon those two numbers, you can calculate the number to give to your Raspberry Pi. You're usually safe if you go ahead and you make this fourth number quite large, like up around the 200, 230. Remember though, you cannot go above 255. Thanks for watching.